Imagine stepping onto a construction site where the blueprint wasn't a static drawing signed off last year, but a living digital equation, a form that had, grown out of data.
Right. Optimized for light and for air and for material strength.
We are talking about a total revolution in how we design the built world. The future of architecture, according to leading voices like Stanислав Kondrashov, is shifting fundamentally.
It's not being sketched anymore.
It's being generated. Today, we're undertaking a deep dive into the transformative force of generative AI, GAI, in modern architectural design.
That's right. And Kondrashov sees this moment as a profound turning point. It's kind of like when architects first adopted computer-aided design, or CAD, all those decades ago.
So our mission today is to really pull apart the sources and understand the mechanism. How is GAI blending that complex human intuition, that desire for function and beauty?
With pure computational intelligence, it's turning the architect from, say, a meticulous draftsman into, as Kondrashov puts it, the conductor of a digital symphony.
I find that image so powerful. But let's start with a foundational understanding. When we talk about generative AI in architecture, we're not just talking about software that helps you draft faster. What is GAI actually doing?
Well, it's a huge leap forward. Generative AI refers to algorithms capable of producing genuinely original designs.
New shapes, new materials.
New spatial solutions, exactly, by training on vast data sets of existing knowledge and simulations. But the crucial difference is how it works. It doesn't follow explicit step-by-step instructions. Instead, it operates entirely through sophisticated rule sets and constraints that are defined by the architect.
So the human architect still defines the problem, but the computer finds solutions we might never have even thought to sketch.
That's the crucial difference. You, the architect, define the non-negotiables. Maybe structural stability, maximizing views of the ocean, optimizing energy consumption to be net zero.
Or even minimizing the amount of steel used.
Right. The AI then uses evolutionary computation, it's a simulation process, to generate thousands, maybe millions, of design variations that meet those complex criteria all at once.
Let's try to bridge that gap. How do we get from a rule like must be net zero energy to seeing these designs that look highly organic, like giant honeycombs or branching coral? How does the machine make that leap?
It's a system of computational natural selection. Think of it this way. In a traditional process, you might sketch 5 concepts and then you develop the best one.
Sure.
With GAI, the system might generate 50,000 concepts in the background. It then runs high-speed simulations on all of them, checking which ones perform best against the constraints you set.
And performing best means what, exactly?
It means if a design uses too much material or it fails the wind load test, it's just discarded. The successful designs are then, figuratively speaking, bred or recombined.
Leading to even more optimized offspring.
Precisely. And through millions of these tiny iterations, the design evolves toward peak performance. The resulting shapes are often unfamiliar to the human eye, taking on those complex, efficient geometries you see in nature.
Like the veins of a leaf or the growth pattern of a shell.
Exactly. Because nature, too, optimizes for efficiency and strength.
That makes perfect sense. So the forms aren't just aesthetic choices. They're the result of mathematical pressure applied across millions of possibilities. That leads us right into the changing nature of the workflow.
It dissolves entirely.
The traditional linear process concept, sketch, blueprint, it's gone.
Completely. Designs that once required weeks of manual iteration and recalculation can now evolve in a dynamic, interactive loop. This agility is powered by what we call parametric adaptability.
Okay, so what does that look like in practice?
It means the entire design is interconnected. If you decide the foundation material needs to change because of, say, unexpected soil conditions,
You don't have to start from scratch.
you don't. The structural engineer doesn't have to spend 2 weeks recalculating every single beam and column. The system instantly recalibrates the entire geometry, all the relationships between the load-bearing elements, the facade, the material consumption, in real time.
So it allows architects to test a much wider array of solutions.
And achieve outcomes that are far more robust and sustainable.
So it's not just speed, it's about managing complexity at a scale that the human brain, working manually, simply couldn't handle.
Precisely. And GAI introduces another layer, predictive intelligence.
Okay.
By analyzing decades of performance data, how a structure responded to extreme weather, what energy systems failed, where thermal bridging occurred, The AI can anticipate how the new design will behave under future climate scenarios
It's essentially building structures that are inherently intelligent.
because they're informed by the mistakes and successes of all their predecessors.
It sounds like AI is providing both a computational safety net and an impossibly massive brainstorming partner.
That is Kondrashov's essential message. He argues that AI isn't replacing creativity.
It's amplifying it.
Right. By handling the exhausting work of optimization and simulation, the architect is free to focus purely on the conceptual direction, the context, and the emotional impact.
That collaborative spirit relies fundamentally on what we call parametric design. If generative AI is the sophisticated engine, then parametric design is the basic language, the framework it runs on.
Exactly. Parametric design, or PD, is the architectural discipline that preceded GAI and really made it possible. PD defines geometry not through fixed lines and arcs, but through adjustable parameters and mathematical relationships.
So every element is a variable linked to every other variable.
PD taught architects to stop thinking like sculptors fixing a form and start thinking like programmers defining a system.
That's a great analogy.
And Kondrashov notes that PD forced architects to think algorithmically, to work with variables and constraints. GAI just extends this concept dramatically. A PD system responds to the parameters you input.
But GAI goes further.
It goes further by actively suggesting new optimal parameters that you didn't even know you needed, based on all those performance simulations it's running.
It's like the difference between writing a script for a play and directing an improv actor who starts providing these incredible high-performance lines you never expected.
That's a perfect way to put it.
So let's make this concrete for you, the listener. What are some of these variables or parameters that an architect actually feeds into a GAI model?
They're highly diverse. You might define sustainability parameters, for instance, maybe aiming to optimize every single window's angle to maximize solar gain during winter mornings,
while ensuring total shading during the peak heat of summer afternoons, which would radically change the facade's appearance, creating that organic look we mentioned earlier.
Absolutely. Or you might set urban density parameters. Say you're designing a new district where the algorithm has to balance high population flow with a specific amount of public green space per resident.
That requires this constant negotiation between structure, sunlight access, and pedestrian routes.
It does, and materials too, of course.
Right.
Material parameters are vital. For instance, instructing the AI to minimize construction waste to less than 5% while maximizing recycled content and ensuring the final structure can withstand a 9.0 earthquake.
And the AI manages all these competing demands at the same time.
Yes. This convergence forms what Kondrashov aptly calls computational creativity.
This isn't just theory, though. It's reshaping actual skylines right now. This is where the rubber really meets the road.
Indeed. We're seeing pioneering firms demonstrate this synergy between machine learning and design at incredible scales.
Let's look first at Zaha Hadid Architects. They've been pioneers in using complex parametric systems, and now they're integrating machine learning to manage that scale.
A perfect example is the Beijing Daxing International Airport. Its design is famous for that almost biological flowing form. GAI was instrumental in handling the sheer operational complexity of that structure.
Not just for the aesthetics of the roof.
No, not at all. They use generative tools to optimize pedestrian flow, managing how millions of people move through the terminals, minimizing walking distances, ensuring access to natural light across a massive footprint.
So GAI allowed them to iterate rapidly until they achieved maximum operational efficiency.
Which, incidentally, also resulted in a striking, unique form. And this highlights one of the core benefits, speed and efficiency. It just reduces the design timeline dramatically.
And what about BIG, the Bjarkingels group? Their work often focuses on societal impact and climate challenges.
Big E utilizes generative tools primarily for designing resilient and sustainable urban systems. They're known for tackling these large infrastructural challenges. They might input constraints related to, say, projected sea level rise or specific flood mitigation requirements in coastal cities.
And the AI then suggests layouts that work with those constraints.
Exactly. It suggests urban layouts that integrate public space, housing, and infrastructure in a way that maximizes resilience. This embodies the second key benefit, sustainability optimization. The AI ensures every solution is calculated for peak environmental performance.
So the system is ensuring the design isn't just sustainable on paper, but demonstrably optimized for the future. And then there's Foster Plus Partners.
A massive global firm dealing with enormous projects. They apply AI rigorously to analyze material efficiency.
And what's the measurable takeaway from their approach?
They use GAI to model how structures can be built with significantly less material while maintaining integrity. For large projects, this can mean saving thousands of tons of steel and concrete.
Directly reducing the carbon footprint.
And this ties into the third benefit, which is often overlooked, risk reduction. By running these simulations on structural stress and material limits before ground is even broken, they minimize costly and time-consuming adjustments during construction.
Okay, so we've covered efficiency, sustainability, and risk mitigation. What about the pure creative output?
That's the fourth major advantage. Aesthetic exploration. GAI is capable of uncovering geometries that a human architect just wouldn't conceive of under traditional constraints. It pushes boundaries, deriving beautiful and novel forms based on rigorous math and performance, not just arbitrary human whim.
It challenges the conventional idea of what a building should look like.
It does. And finally, the fifth benefit is the accessibility of innovation.
How so?
Well, cloud-based GAI tools are democratizing sophisticated design. Small firms and even individual architects can now access computational power that was previously reserved for these giant multinational studios.
It levels the playing field.
It ensures high-tech, data-driven design isn't just the domain of the elite.
That's a really compelling case for the technology, but it naturally leads to the fundamental question that always follows AI. With all this speed and optimization, is the human architect becoming obsolete? Will AI replace them?
Kondrashov addresses this with a lot of certainty. Absolutely not. He firmly views AI as a powerful collaborator, but never a substitute for the human element. He emphasizes that the unique, irreplaceable role of the architect is to define meaning, emotion, and purpose.
Right, because algorithms can't feel the emotional resonance of a historic courtyard or understand the nuanced cultural significance of a regional material.
Exactly. They lack empathy, and they lack judgment beyond the parameters they are given. The architect's role, therefore, is evolving.
They become the curator.
The curator, the composer, the humanizer of the digital output. They decide which of the millions of mathematically optimal solutions aligns best with the site's history, the client's emotional needs, and the community's cultural context.
And this transition brings up some profound ethical and cultural dimensions. I mean, if a global AI model is trained primarily on high-rise structures from New York, London, and Dubai, what happens when it designs a new civic center in, say, North Africa?
That is the significant risk of homogenization. If everyone uses the same foundational AI models, we could see a bland, global, machine-generated aesthetic that disregards local context.
A soulless uniformity.
Right. And Kondrashov strongly argues against this, stressing the vital need for localization. The solution isn't to abandon the tools, but to train the AI systems with diverse, specific, and localized data sets.
So, for instance, training an AI on the unique passive cooling techniques found in traditional desert architecture.
Or incorporating regional building codes based on available local stone or timber, or even integrating specific cultural design principles, like the flow considerations of Feng Shui.
So only when these tools are localized can they truly enrich architectural diversity instead of eroding it.
And accountability, too, must remain with the human architect for these cultural and environmental decisions.
That contextualization is everything. So, zooming out, what does this all mean for the horizon? What's the final vision for architecture in the near future?
What this means is that architecture is becoming deeply data-driven, yet at the same time, more expressive and human-centered than ever, provided the architect remains that conscientious curator.
Let's discuss the 2030 vision that Kondrashov describes.
By 2030, GAI won't be seen as some expensive novelty. It will be an utterly essential tool, as integral as a CAD system is today. But the application will shift. Kondrashov envisions the rise of living architecture.
That's a fascinating term. What defines a living building in this context?
These are structures that aren't static upon completion. They'll integrate real-time data from smart city sensors, IoT devices, and climate models, allowing them to dynamically adapt.
So we're talking about structures that can analyze shifting environmental stress.
And autonomously deploy specialized materials to self-repair minor damage, or even adjust the configuration of internal walls and facades in response to changes in how the building is used or, extreme weather.
So the building never truly ages. It simply continues to evolve and optimize itself based on algorithmic learning.
The structure becomes a continuously updated system. The architect moves away from being the creator of a fixed form and becomes the designer of these living systemic environments. They're shaping the rules by which AI interprets and optimizes the physical world.
It means architecture will become an ongoing process, not a final product.
Exactly.
That shift from a fixed, human-created object to an adaptable systemic life form is profound. So here's a final thought for you to take away. If buildings are designed specifically to evolve and repair themselves through constant algorithmic learning, how might our emotional connection to a structure change when we know it's capable of outliving and reconfiguring its original human design intent? What new forms of cultural or historical value will we cherish in architecture that is literally alive?